Hey, what's up everybody? Today we're going to be replacing the output transformer on a Fender Blues Jr, which, if you know anything about these things, you know that they're a pretty good sounding amp with a lot of really bad design flaws and a lot of failure points. So my goal ultimately is just to kind of beef this thing up and bulletproof it as best I can without spending a lot of money, because it's not an expensive amp. So there, as I said, are a lot of design flaws with this amp. It's just kind of the nature of it, and it doesn't seem like they've fixed any of it over the years. There's, I think, 4 different versions of it out now, and there's a lot of places that are pretty well documented that these things fail. The first thing is that it looks like Fender cut every corner possible in sourcing components for these things. They're just full of cheap bullshit, and that's an easy enough fix, right? The other problem that you run into more frequently is that the tubes are board mounted, and they're mounted on a separate PCB, and rather than spending the extra time and money on it, they created these single-sided PCBs, which, as you can tell, are a consistent point of catastrophic failure. There's traces that just run too close together with high voltage on them, and you see this a ton in these. It also, when you have that kind of failure on one of the power tubes, and something arcs over like that, who knows what it's gonna pull with it. So that is a problem that's a little tougher to mitigate, although there are a lot of aftermarket boards that you can buy now that are good quality, double-sided. They've rerouted the tracing. The one that I purchased actually has 1 ohm resistor mounted in line with the plates, so you can take your voltage readings and bias the thing properly. So again, that's something that you're going to have to contend with. It's not an amp that is worth putting a ton of money to, and I'm already kind of upside down in this thing. I bought it at a local repair shop that was closing down. They had a yard sale. I picked it up for super cheap and figured maybe I can fix it and flip it. However, by the time I replaced the crappy Illinois filter caps and put a new board in it, retube it, and as I mentioned, put a new output transformer in it, which we're going to do now, I'm already pretty deep in this thing. I doubt I can flip it for barely what I've got in it. So anyway, I'm just fixing it for the hell of it. So let me show you what I've done already, okay? So as I've mentioned, we have replaced this tube board altogether, and I kept the ribbon cables except for the one that was totally smoked. I don't love the ribbon cables, but they were already in place, and I'm trying to do as little on this as possible. The other thing I did, I took out those crappy Illinois and I put FTs in there. What did we do? We beefed up the dropping resistors there. I put a variable bias on R51, R52. That's usually a 22K and a 33K in there, and they are notoriously hot, as Norm Macdonald say, hotter than a $2 pistol coming out of the factory. And as a result, they at the very least burn through tubes super quick, and at worst you have this kind of situation. So we'll take care of that so we can bias it a little lower. I also changed these plate resistors because they were woefully underpowered, so I put some 3 watts in there, and hopefully that will keep anything bad from happening there. I also pulled, they had some of these, got rid of these. These are what they were using for the coupling capacitors, and so I replaced those with Mallory axials. Like I said, I just had them laying around. On any other occasion, I probably would not have bothered with them, but that's what it is. So in doing all this, we run through and I started working with the voltages, and I discovered really quickly when I brought it up on the Variac without tubes that it was pulling a ton of voltage to ground. I pulled the power transformer, tested that. Power transformer tested fine. I took readings on the output transformer, and the resistance, you know, just doing down and dirty readings on it seemed okay. But when I powered it up and I plugged them in, I was seeing voltage fluctuation all over the place until I pulled the center tap, and then the voltages went back to normal. So, you know, that was a kind of a quick and dirty way to diagnose a bad output transformer. And once I had kind of found that, I measured the center tap to ground, and it was showing about 500 ohms resistance. So that is where I was losing all my voltage. So therefore, we're going to replace it. I ended up, again, trying to find something that was going to be suitable. This is what I ended up with. There's a lot of parts, places, and manufacturers that make replacements for these. Again, I just don't see throwing in a mercury output transformer on this amp. It just doesn't make sense financially. So what I ended up with was a Hammond 1750F. At the time I'm recording this, I sourced it from DigiKey. That seemed to be the cheapest I found it, at roughly 50 bucks with shipping. And this one is, let's see, yep, it's an 8 ohm, and it's almost 7K, 6,950 ohms center tap. So it's pretty close to the stock one that came out. Hopefully it is just kind of a plug and play type of deal. And in fact, this one already comes with the little spade connectors on it, so this should be really easy operation. So as you can see, these things are pretty tight. You know, it takes a little work, and if you're not used to working with this kind of stuff, be really careful if you have to pull this board, because man, they really kind of cram it in there. And those ribbon cables are notorious for breaking internally or at the solder joint. So that can be a real source of frustration if you get everything all buttoned up and you think you're done, and then you start, you know, feeding voltage into it, and all of a sudden you find yourself with a new problem. So we have got this pretty much removed. I'm going to take this little ground lead off. Move the board out of the way. You can see these. You can also see the mark where this thing flamed out. So it's no wonder that the output transformer is gone on it. You know, you always kind of hope that that's not the case. However, you know, that's what it is. And I did clean that as best I can. It got all the soot off the board itself, off the main board, but it was a little trickier getting it off this chassis. So I guess it's just gonna have to stay like it is. Gonna get in here and drop this second bolt. And this guy should come right out. Yeah, and just like that. Oh, drop the hardware. Don't want to do that. Hold on to my hardware here. So then you can just feed this guy out. This one's got some grommets. I've got my leads taped up, so I should have taken that off before I dropped it, but whatever, this thing is going into garbage, so no sweat there. And looks like, yeah, I'm gonna have to pull these spade connectors out one at a time because it's kind of a tight fit. Let's see, there's my blue out first. I'll pop that grommet out. That'll make it a little easier. And there they go. Yeah, that looks like visible damage right there, so I guess I shouldn't be surprised. It smells a little funky, so there you go. And that's the part number for that one. This looks to be, yeah, it's pretty much identical. So it should be an easy job. We're just going to throw our secondary leads back through this grommet one at a time. I wonder if the blue leads on this are a little bit longer, because that's something I noticed when I was tinkering around with it, is that, man, this blue lead and its connection point on the board is a tight fit. So yeah, it looks like I got a little extra length, which is going to be helpful. So let's do that. Snap that grommet back into place. Throw our secondaries back through there. Yeah, nothing to it. See the other side. And that's it, nothing to it, right? So the hope is that now that we have that done, we will be able to button everything back up and get a signal out of this, or at least get the voltages back to where they should be. And that's the main thing. Once I have brought it up on the variac and made sure that the voltages are now where they should be, we can plug in some tubes and start trying to run a signal through. So I had missed plugging in one of the switch wires, so we were getting some funky readings. Anyway, I got it back plugged in. We're at 40 volts, 42 volts on the variac through bulb limiter, which is showing 122 there, 122, 122, 123, which is all really what you would expect to see with a third of the voltage running in here. So let's go ahead and crank this up. We'll dial it up to 120, standard wall voltage in the US, and take our readings. It's a little hot, 123, dial that back. There we go, 118. That's gonna be close enough for government work. 119. So let's check our 326, right? Plate voltages, 339, 339, that's looking good. 340 on the center tap, that's where we were losing voltage right there. So my hope is I can button this thing back up, we'll pop some tubes in it, and go through the rigmarole of firing it up, and hopefully we can get some sound passing through this thing. Got our tubes in, got a signal injecting, and clipped in there, and there we are, passing a signal. So just put it back in the box. So here we are. We got it back in the cabinet. The reverb pan hooked up, speaker hooked back up, and you know, it's a really nice sounding little amp. And even the reverb, a lot of people complain about the reverb, but to my ears it sounds pretty good.